Now, as I mentioned in section 5, what we're going to be doing is using all these tools that we've developed in techniques to now solve radical equations. Now, these are the steps, and I will be showing them to you as we go along. If you'd like to include any of this in your notes, you can pause it and write them in. And if you were reading your textbook, of course, you would find these there as well. Okay, so example 1, you are to write this down. And we have it there. So, what do I do to get rid of a radical sign? And the key is, whatever number is in the index position, you're going to raise that radical to this index number exponent. So in a sense, you're going to square this, and if you do it to that side, you must do it to the other side as well. So this is a 2, this is a 2. Squaring this just gives you the radicand. So we get this. And we square this and get 49. And now we bring our 49 over. Becomes a negative 49 on this side. Negative 49 and 13 give me a negative 36. And then we use, from a previous lesson, factoring to solve the equation. Now this is the difference of perfect squares, so we'll factor into its conjugates. And then we equate each of these to 0. And we get here x equals a negative 6. Here x equals a positive 6. And if we put those values into the original equation, these are the solutions. So we'll take a look at what the book is giving as a proof here. This is what we showed you. Solve by factoring, and these are the answers. And they check them and they both work. Okay. All right, for example B, again, we want you to pause and write this down. And what is the rule for getting rid of the radical sign? Well, whatever the index number is here, we raise it to that power. But if we do it to one side, we must do it to the other side. So we're going to square this, and we're going to square that. So now this side just becomes the radicand, y squared minus 10y minus 11 equals, now that special technique, square this first term, that's 1. Multiply these two together, double it, that'll be a plus 2y. And then square this term, which is going to be a y squared. So again, using techniques that we worked on in the past, and now what we can do is we're going to subtract a y squared from both sides. So these just go away. And now we're left with a rather simple equation. And we want our y's to be positive. So I'm going to transpose this negative 10y to this side. So this will become 12y here. I'm going to transpose this 1 to the other side, where it becomes a negative 1. So this is negative 12. And then I divide both sides by 12. And I get y equals a negative 1. Now, even though this is looked like a quadratic equation, y to the second, they disappeared. So you're only going to end up with one solution. So y equals negative 1. And our book is going to check it, I'm assuming. And there is our answer. Now I see they're doing it a little different way. Again, there's different ways to solve. And if you put a negative 1 in there, it works. Okay. Again, for example 1, letter C, you want to copy this down, and as part of the rules, we want to isolate a radical on one side. So to isolate this part here, I have to take this positive 3, transpose it to the other side, where it will become a negative 3. So let's do that. So we have the square root of 3x plus 13 equals 2x, transposing that, a negative 3, or just subtracting 3 from both sides here. Now, what's the rule for getting rid of a radical sign? Well, whatever the index number is, we raise that to that power. But if we square this side, we must square this side. So this side will just become the radicand, 3x plus 13. Now I'm going to use that special technique of squaring a binomial. We square this, this becomes 4x squared. We multiply these two together, get 6x, negative 6x, double it, negative 12x, and then we square a negative 3. Negative 3 times negative 3 is positive 9. Now our next step is to move all of this over to the other side, so we end up with an equation in standard form. So this is going to be 4x squared. Now we're going to subtract 3x from here. 3x from there will give us a negative 15x. We're going to subtract a 13, so that's negative 13, negative 13. This gives us a negative 4. Now there's no common factor that we could take out of each of these. And the only way we have so far to solve quadratic equations is by factoring. So we will factor this. And since my middle term is a negative 15, I believe this is going to be 4x, x, 4, 1. And my signs now, I need a negative 15 in the middle, so this is a 16. So if this is a negative 16x, and this will be a positive 1x, adds up to this, so I have factored that correctly. Now I equate each of these factors to 0. So 4x plus 1 equals 0, or x minus 4 equals 0. This ends up being a negative 1/4. fourth. And here this is an x equals 4. All right, we're going to do the check to see if these, in fact, are the proper answers. So they're transposing, they're squaring both sides, they're bringing it all over to this side, they're factoring, and these are the answers they're getting. So when they check them, and that's the tedious part here, they find that one of the answers doesn't work. Ooh. But how about the 4? So the 1/4 didn't work. But the 8 does. And this is the nature of working with equations that have radicals in them. By squaring things, we sometimes develop what are called extraneous roots, or solutions that aren't really solutions. So here it becomes very critical to check your work. Now, in MATLAB, when I see something like this, and the student has done all of this work, and you put in there as one of the solutions a negative 1/4, and you say the other one is a 4, that's what you got from solving the equations, they're going to count that wrong. But, as you can see, we're going to give you lots of partial credit for that, because you did all of the work to solve it. So that's our promise to you. Okay. Let's go on. Now, as we look at this last example here, of example 1, we see we have a square root of something equal to a negative 3. Well, we had said that you can't have, underneath the radical sign, a negative value. That's not a real number. So for something like this is what they're going to say. There is no real solution. Okay? Now, you can solve it and square it and do everything and get an answer, but that's not going to make it a true statement. And they'll show it to you here. So they'll say that it's 8. So when we do the check and put an 8 in here, this becomes, on this side, a positive 3. But a positive 3 does not equal a negative 3. So keep that in mind. Now, again, I would be sort of in the position of giving you partial credit for this, because you were following a protocol. And, you know, we're interested in that as well. What the real answer for this is that there's no solution. Okay. Again, you have that in your notes. This is something you would study. So they're saying it is possible that after checking the answer, you may find that none of the answers are solutions. In this case, the answer is no solution. Okay, we're now going into solving equations with 2 radicals. So again, pause for a moment. Write this into your notebook. And what do we do here? Well, the same technique. To get rid of a radical sign, we raise it to the index number power, and it just becomes the radicand. X plus 4 equals 3x minus 2. So we're going to take our x to this side, subtract it or transpose it. This becomes 2x. Add 2 here or transpose it. This becomes 6. Divide both sides by 2. X equals 3. Now if we put a 3 in there. Let's see if this in fact would be a solution, because you really need to check these. X equals 3. And it checks. The square root of 7 equals the square root of 7. So 3 is an answer here. Now, here it gets a little tricky, and this one, will take some time to work it for you. But again, the technique is to isolate one of the radicals. So we're going to take this and transpose it to the other side, where it just changes the sign. So this is what it'll look like. We'll have the square root of x equals, we'll leave the 1 there, but transpose this just changes its sign. So this becomes plus the square root of 2x minus 14. So far, not too bad. We've isolated one of the radicals. So what do we do? Well, we're going to square this side. And we're going to square this side. So squaring this side, this just becomes the radicand, which is x. But now we have to square this binomial. So we square the first term. That gives me a 1. 1 times 1 is 1. We multiply these two together and double it. So it would be 1 times this. So this is going to become 2 times this. And now we square this, and it just becomes the radicand. So we have here plus 2x minus 14. That's where that technique is good, and hopefully you've mastered it by this time. Now, we want to, again, isolate this radical here. So we're going to take this to the other side. Well, first we can group this. 1 and a negative 14 gives us a negative 13. In fact, let's just do it in steps so we don't get too confused. This is now going to be a negative 13. And we're going to take this plus 2x, just kind of moving this around again. And we have then plus 2, the square root of 2x minus 14. Okay. So now we're going to take these and move them to the other side. So this negative 13 on this side becomes a positive 13 on that side, just transposing that. And this will become a negative x on this side here. And then we have 2, the square root of 2x minus 14. So now what we're going to do is square this side and square that side. And since the book has it written out so nicely, I'm going to use it. So we've taken this to the other side. We've squared both sides. So this side becomes x. We squared this. That would be a binomial square. That's what we got. We're going to combine like terms here. There's our 13. Now this is where I ended up with u. So now we're going to square this side here. And they're going to square this side. So squaring this side gives you x squared minus, again you're multiplying this times this, get a negative 13x, double it, gives you a negative 26x, and you square 13 and you get 169. Now here's a little bit tricky. When we square the 2 here, we get a 4, and then it just becomes this radicand. So we have to multiply through here to get rid of this parenthesis. And we get 2x minus 56, and we have this trinomial. So again, we want to bring everything over to this side. And when we subtract 8 from here, this becomes a negative now 34x. When we add 56 here and add 56 here, it gets 225. And again, the only technique we have is factoring. So this one was a little challenging, but it factors into this. So what are our answers? We equate each of these factors to 0, and we get x equals 9, x equals 25. But the key here is you have to check whether or not these answers are going to be, in fact, solutions to the original equation. So when we put 9 in there, we end up with 1 equals 1. So the 9 is a solution. When we put the 25 in there, we end up with negative 1 equals 1. This is not a solution. So again, when we start to square things, we introduce what are called extraneous roots, things that are not solutions. But again, I would give you super partial credit for doing all of this, but you need to check your answers, because it may be that one of them does not make the original equation true. So 25 is not a solution. The only solution is 9. Okay, now we're going to take a look, and we're running a little over 20 minutes, but we'll stay with it because we're almost finished. What do we do if it's to a third root? Well, again, you want to isolate the radical, and this will become the third root of 2x plus 1. We're going to take this positive 1, transpose it. On this side it becomes a negative 1, so this is just going to be a 2. Now, how do we get rid of a radical sign? Well, we raise it to the power of the index number, and then it just becomes the radicand. So here, this to the third power just gives you 2x plus 1 equals 8. We transpose the positive 1 to the other side, becomes a negative 1. So we have 2x equals 7. And then x is going to be 7/2. So even though it may have looked challenging, that techniques that we've developed, and of course there's a lot of arithmetic in watching your signs and doing the proper things here. So we've transposed the 1, we cube both sides, and we get this as our solution. Now if we put that in our original equation, 3 does equal 3, so that is the solution. Okay, well, we went overboard. You're going to have your practice. Again, you certainly can watch a video like this again to have it drilled and repetition to develop your mastery and to get certification. All right.